Yes. Hi everyone. I am SS Kiran. I am dealing course is electromagnetic waves and transmission lines. Okay. In this video, I would like to discuss about Biot Savart's law in magnetostatic fields. Okay. This chapter is magnetostatics or magnetostatic fields. You may call any type, no issue. So today's topic is Biot Savart's law in magnetostatics. Magnetostatics, right? Okay, this is unit 2, right? Now, magnetostatic fields. Today's topic is Biot Savart's law. Biot Savart's law. Okay. Before going to this definition, first, I would like to concentrate on graphical representation of how the magnetic field DH produced at point due to current element ideal. Okay, let us consider one conducting wire. Okay, the flowing of current in this conducting wire is I. Consider differential length on this wire, treat as dl. This is differential length denoted with dl. The current differential element is ideal. Now the magnetic field intensity produced at point P denoted with dH bar. So this is point P. The magnetic field intensity dH bar. So this cross mark indication inside of the inward of the field. Now this point is P. Now the line joining between this differential length and this point P, the distance is R. Okay. Now I will go with the definition based on this representation. Okay. Now Biot Savart's law states that the very important discussion states that the magnetic field intensity dH bar produced magnetic field intensity produced at a point P as shown in the figure, right, by the differential current element. This is current, this is differential element. Ideal is proportional to the very important. Ideal proportional to the product means I into dl, I cross dl, product of ideal and there is an angle between alpha, this is angle alpha, between the element, this current element, and the line joining P to the element. Okay, ideal and another extension definition, the sine of the angle angle alpha between the element and between the element means this ideal and the line joining, and this is called line joining P, and the line joining P to the element, and one more point, inversely proportional to the square of the distance, and inversely proportional to the, I will write mathematical form also, inversely proportional to the square of the distance, inversely proportional to the square of the distance. While writing the definition, every keyword is very, very important, right? As it is, to the square of the distance, that is called R, square of the distance, R between P and the element, R between P and the element. That's it. Okay, this is the definition of the Biot-Savart's law. Once again, I will tell you about Biot-Savart's law. Biot-Savart's law states that the magnetic field intensity dH bar produced at a point P, okay, as shown in the figure, ideal is proportional to the current element, differential current element ideal, and the sign of the angle alpha between the element and the line joining P to the element, and inversely proportional to the square of the distance R between the P and the element. Now, the mathematical approach of this magnetic field intensity DH is directly proportional to the product of ideal and angle between the line joining of P, ideal, product, and sine alpha, and inversely proportional to the square of the distance, then 1 by R square. Now, I will write another way of this magnetic field intensity, DH bar, field is always having vector, okay, DH bar equal to, so proportionality constant is placed here, K into ideal sine alpha, right, as it is, there is inversely proportional R square. Okay, this is about expression of this DH equal to, where K equal to 1 by 4 pi. Okay, now this is the final expression. I will write here DH equal to ideal sine alpha, the product of differential current element to the sine angle between the line and point P, 4 pi constant, 4 pi R square. Okay, now there is another extension is there. For example, A bar cross B bar, you may write mod A bar mod B bar and sine alpha. Okay, again I will write this one with the help of this I dl and AR bar unit vector. Now I will extend this one. I will write as it is dl bar cross AR bar is a unit vector. Write as it is this 4 pi r square. For example, this dl bar, I may write dl as it is. AR bar unit vector, the mod is 1, then the angle is sine alpha. Okay, now I will extend this expression I into dl. AR bar means r bar by r unit vector dl. So dl cross r bar by this 4 pi, one on another r is added, then 4 pi r cube. Already I have discussed in detail in Coulomb's law. Okay, this is the final expression dh equal to idl cross r bar by 4 pi r cube. Okay, this is very important expression. Now I will discuss same thing in line current and surface current and volume current. So there is some extension discussion is there, approximately equal to this ideal equal to surface also. Then I will write KDS approximate equal. So mention this one, and approximate equal to JDV also. Okay, JDV. So now I go with the line current and surface current and volume current. I will write one by one the expressions. Please note down. Okay, this discussion is very helpful for writing the end examinations. Now, the final expression here, differentiation, then final expression h equal to, so if you do both sides integration, finally h equal to L IDL cross AR bar by 4 pi r square. If it is r bar, I can write r cube. So this is for line current. Then I will go with the surface current. So vector is compulsory. H bar equal to KDS with respect to AR bar by 4 pi r square, 4 pi r square. So then implies another expression for H bar. This is for surface. Now I will go with volume. So here I will mention this is yes surface. Then this is V for volume. JDV. Okay, JDV cross AR bar by 4 pi into r square. Okay. Now, if I considered some graphical representation, so if it is line, I may consider small length. So this is called IDL. This is for line IDL. For example, if I consider surface, very important representation. This is for surface. So first I will take the field. So surface is very important. So this is called K. Now I will extend this one K into DL. Okay, for example, if it is volume, very easy, like a small. Okay, now here considered rho V. Okay, or dV J into J bar into R dV, or simply you can write J into dV, considering the volume. Now, the final expression for DL or H, just remove this AR bar. Now, this is very, very important. H bar equal to integral IDL into R bar by, then write as it is, this 4 pi. Now R square is converted to R cube because of unit vector R bar by R. Okay. This is about final discussion. Okay, I will take the box of this expression, this final magnetic field intensity, very, very important. Magnetic field intensity. Now I will go with another representation, field point P due to straight filamentary conductor. This is very, very important discussion. Please concentrate here. I will take one triangle here. Okay. Now there is one point is there. There is one point is there. That is called inside into the page. So indicates the cross. This is point P. Consider one differential length IDL. Okay, then simply I will write IDL. Now, so there is angle between this IDL and this P. I will draw straight line. Okay. Now, this is the angle. This is the angle alpha. Now consider two references point. This is B and another one is A. Already I have discussed in electric fields due to continuous charge distributions. Same discussion. So better take another references points also. Okay. Now this one also. Arrange this one. Okay, now this is about alpha 2. This is about alpha 1. So the distance of this line joining this is called R, or simply you can write R. If it is vector, you can write R bar. But this is the rho. This is horizon. This direction indicates Z. Okay. Now write all the trigonometric expressions also, very, very easy. No need to worry about this part. Now I will extend this one. Now first I would like to start with R bar. How we can write R bar? Very simple. If this is horizon. Okay. 0, 0, 0, x, y, z. Now this is in the place of 0, 0, z. Then I will write xa x plus ya y plus za z. Now r xa x plus ya y, simply I can written as r arrow bar. Already I did everything in electrostatic fields in continuous charge distributions. Now finally I will write R bar equal to rho into a rho bar minus z az bar. So doing the mathematical part, this is about the R bar. Now the length dl equal to, now the direction is z side. So dz into az bar. Okay. Now substitute in this expression h bar equal to IDL into cross R bar 4 pi R square. Okay. Now very simple. Before going to this discussion, first I will write DL cross R bar. So what is the DL cross R bar? Now a rho into az rho comma pi comma z. The resultant is pi. Now the finally rho into dz as it is, dz, then rho a rho cross az, then I will write a pi bar. Okay, az cross az 0, no need to write this one. Now I will substitute one by one in this expression. Now finally h bar equal to integral rho, at the same time I is also very important, I rho dz by, right as it is, this 4 pi, this r cube and this r bar is also very important. Okay, this r bar means what? Already this dl bar cross r bar, the final expression is rho az and a pi bar. Okay, already I had derived about this r bar. Anyway, this is the final discussion. Now I will write a small extension part of this one. So first of all, I will write, there is one expression is there that is called rho. First I will write with cot alpha. What is the meaning of cot alpha? Adjacent side by neighbor side. Okay, I opposite side. So I will check it about cot alpha. Cot alpha equal to z by rho. Then finally z equal to rho cot alpha, doing differentiation both sides, dz equal to minus rho into this cot alpha means cosecant square alpha with respect to d alpha. Same cosec, same, I will extend this one. Cosec alpha equal to this one, I have to extend this one. Cosec alpha equal to r by cosec alpha equal to, so this is cosec, actually sine means opposite. First I will write r by rho. Here this is the rho, so I will write as it is rho. Finally r equal to rho cosec alpha. Okay, later we will discuss about this r and everything. Okay, now I will extend this one. H bar equal to I into rho dz means this is minus, I will write as it is, rho into cosecant square alpha with respect to d alpha. Then write this is 4 pi is common, 4 pi is constant. Now this is r cube. So what is the meaning of r cube? So simply I will write, I will extend this one, r equal to rho into cosec alpha. Now here r cube is there. R cube means r cube, rho cube, cosecant cube. Now h bar equal to minus I by 4 pi, and one more rho is also there. So rho square integral rho square cosecant square alpha by rho cube cosecant cube alpha with respect to d alpha. This square and finally get cancelled. The resultant is h bar equal to minus I by 4 pi. There is a limits. A pi bar is also very important. How to write this one? A pi bar. The resultant h bar equal to minus 4 pi. This r cube. So one row get cancelled, 4 pi row with direction a pi bar. In the integration alpha 1 to alpha 2. Finally, this is sin alpha with respect to d alpha. Doing integration part, there is integration of sin alpha. Okay, the resultant is cos alpha. So substitute this 1 by 1 minus cos alpha minus get cancelled. Finally, h bar equal to 1 by 4 pi rho cos 1 by rho cos alpha 2 minus cos alpha 1 with direction a pi bar. Now considering alpha 1 equal to 90 degrees, alpha 2 equal to 0 degrees, the resultant is h bar equal to 1 by 4 pi rho with direction a pi bar. Okay, because cos alpha, cos 90 degrees 0, cos 0 1. Now substitute these values. Okay, now finally h bar equal to 1 by 4 pi rho into zero bar. Yes, this is about Biot Savart's law. If you go with different angles, alpha 1 equal to 180 degrees, alpha 2 equal to 0 degrees, then final result is h bar equal to 1 by 2 pi rho into a bar. Okay, keep watching. Thank you so much. For example, alpha 2 equal to 180 degrees, alpha 1 as alpha 1. Okay, alpha 1 equal to 180 degrees, alpha 2 equal to 0 degrees, then h bar equal to 1 by 2 pi rho. Okay, thank you with direction a pi bar. Keep watching. Thank you.